Hello, this is a part of programming tutorials on securitytube.net, and in this tutorial I'll be talking more about C pointers. Now C pointers is the most important and most flexible part in C language. Many beginners, many newcomers find pointers little bit difficult. I will try to introduce to pointers with basic concepts and try to deal with it with different programming examples. Before going into details about pointers, having a good knowledge about variables is very important. How exactly variables are stored, I will talk about it first, and then let's go to pointers. So what are variables? Variables have two parts, name and value, and this value can vary. So if I have an integer type of variable, the integer is the type of that variable, and say variable name I have given I. So I is the name of variable and the value of this I will vary. Now what is the size of this variable I, or in other words, how many bytes the compiler will utilize to store the value of I. Now for any programming language, the sizing is not fixed on the programming language, but it depends on the machine on which you are compiling and on the machine on which you are running your code. So for 32-bit machines, generally 4-bit integer, 4 bytes are used to store any integer value. But for lower end machines, even 2 bytes were used to store the integer value. So integer doesn't go always with 4 bytes or 2 bytes, but it depends on the machine on which the code is being written, compiled and run. If we want to find out how many bytes have been used for storing any variable, there is a very handy code, or there is a very handy function sizeof, which gives the size of that variable. So to find out sizes of different variables in C, I have written a simple program. So in hash include stdio.h, I have included standard input output file int main. I have defined one integer I guess this is not required in this program. Let's remove it. Let's remove it. Now I am just printing size of char is %d/n size of char. Similarly, I am printing size of short, size of int and size of long. Let's save this program and let's compile the program with help of GCC. The program got compiled. Let's run a.out, and it has given the output as size of character is 1, size of short is 2, size of integer is 4, and size of long is also 4. So on this machine and this GCC compiler, the sizes of different variables are like this. Now in C programming language, when I define any variable, I am supposed to give two things: the type of the variable and name of the variable. So if I write int abc, the integer is the type of the variable and name abc is the name of the variable. So while compiling, when compiler sees the int part, on seeing int part, it will store, or it will reserve 4 bytes of memory in the PC to store the value of ABC. And after seeing ABC, it will create a symbol table, and in that symbol table, the variable name ABC will point to this 4 byte memory location, which was just now reserved to store the value. So in latter part of the program, if I write somewhere ABC equal to 11, what exactly will be happening? The value 11 will be written at the 4 bytes reserved in the variable declaration part. So in int ABC, it will actually reserve 4 bytes, and in ABC equal to 11, it will assign the value 11 in the reserved part in symbol table. Now in this example, there are actually two values associated with ABC. First is the value which is being stored in ABC, that is 11, and another is the address of ABC at where the value 11 is getting stored. So first is the address and second is the value itself. So this value or the variable value is called the R value or right hand side value of the assignment operator, and the address of ABC is called the L value or left hand side value of the assignment operator. Now at the address ABC, actually we are storing 11. So 11 is the value getting stored at address ABC. So now for example, if I define one more variable, say ABC comma XYZ, okay, and if I assign value XYZ equal to 2, and then I am assigning ABC equal to XYZ, what exactly is happening? In line 1, ABC is equal to 11. 11 is stored at the address location ABC. In XYZ equal to 2, 2 is stored in XYZ. Now ABC equal to XYZ. Now here XYZ is present at the R value part of the assignment operator. So here XYZ is interpreted as the value present at XYZ address, which is 2. So with the expression ABC equal to XYZ, actually 2 will be copied at the address of ABC. So after first statement, the ABC contains 11, and at the end of the program ABC will contain XYZ, is contains 2. So ABC will contain 2. So at the end of the program XYZ as well as ABC will contain 2. Now say for some reason I want to store L value in the variable or address of the variable as a variable as some another variable. Now why I will leave this, it will be more clear in other videos on pointers, but just remember for now, having storing address of the variable itself is a very path breaking thing about C. Once you know and once you get familiar with pointers, the C is just a piece of cake. So say I am storing int asterisk A. Now asterisk A, int asterisk A will tell the compiler that A contains the address of a variable. So A per se will not contain any value like R value, but A will contain an address or L value, and that L value will point to integer. So A is an integer type pointer. Now why it is called pointer, it will be clear in further videos. So as of now you just want to remember that int asterisk A makes A as a pointer type of variable which points to integer. Now few important things about pointers. What is the size of the pointer variable which is used for the compiler? It is again not dependent upon any language or so, but what is the memory content of this computer or what is the memory content of the machine on which your program is running will depend the size or will dictate the size which a pointer variable will need. As of now we are not concerned about that. And second thing is, what is the default value of any pointer variable when it is declared? So at declaration time, if the pointer variable is declared outside of any function, the ANSI C will define the initializing value as null. So as contrary, when any variable is defined outside of any function, the ANSI C defines the ANSI C defaults that variable value to be 0. Similarly, for a pointer variable, it will default the value to be null. So if we want to check whether a pointer value had changed or not, we can compare it with null. Like this is a perfect valid statement. If null equal to A, then do some things. This is perfectly valid statement. I am comparing value of A with null, and if this statement is true, I am going to do something. Now if I want to store some address at just now defined pointer, say if I want to store A is equal to the address of ABC. So this ampersand operator is used to define the address of any variable. So ampersand ABC actually means that A will contain the address of the variable ABC. Now ABC is actually a L value, but when I use ampersand ABC, it is the address, and that address I can simply store with assignment operator to the pointer variable. So ampersand operator is address of operator. So address of ABC is stored at A, and there is one more operator we need to discuss is the dereferencing operator. Dereferencing operator is asterisk. So if I write some program like asterisk A equal to 1 2 3, what will happen? The 1 2 3 value will be stored at a pointer type variable, but it will not store as an address. 1 2 3 is R value. Remember, 1 2 3 is R value, it is not an address. So what is happening? The dereferencing is taking place, and at the address or as the content of the address 1 2 3 will be stored. Okay, as the content of address 1 2 3 is being stored. So if I want to verify this, how can I do this? Printf say value of, now what we have done, we have pointed A to ABC. So now if I print the value of ABC, what should I expect? The value of ABC should be now 1 2 3. In first statement it was 11, then ABC was assigned to XYZ. So after this statement the value of ABC would have been 2. At this statement the A or content of A was content of ABC, which was 2. So at this statement the value of ABC is still 2, but here I am pointing 1 2 3 at the address of A, and address of A was address of ABC. So now the value of ABC should have been 1 2 3 here. Let's compile the program. Test.c, yeah, got compiled, and yes, the value of ABC now would have changed to 1 2 3, and we are right. Okay, now the dereferencing operator can be also used, like say I want to print one more value of, say I want to print value of A itself. So value at A is, say %d, I will also give /n, and here I will write, instead of ABC I will write asterisk A. Now what is asterisk A? Asterisk A will give the value at A. So value at A is asterisk A, should be a correct statement. I will also introduce a /n here, so that output will be printed on a new line. Let's compile the program, and let's run the program. As expected, value of ABC is also 1 2 3, and value of A is also 1 2 3. Why this has happened? Because I have printed the dereferenced value of A. Now dereferenced value A was a pointer, but dereferencing is the getting the value or getting the actual value at that address. I am dereferencing the pointer. I don't want pointer, but I want dereferenced value. So asterisk is dereference operator, and ampersand is address of operator. These are very important two operators with pointer. That's it about pointer. Pointer just deals with defining int asterisk A or something like this, then some address of operator assignments, and some asterisk or dereferencing assignments. And with this basic knowledge you can go about learning trees and many other data structures and making C programs very easy and very beautiful. That's it for the introductory video on pointer. I will be creating more videos on C programming language as well as for some important data structures. Keep following securitytube.net. Thanks.